Okay, so this is a follow-up video, still on section 2.1 in response to a couple of emails I got about using back substitution and parameters. So we're going to kind of talk about each of these separately and leave it to you all to explore exactly how to put them together. So first, let's talk about using parameters. Suppose I'm given the system x plus 3y equals 14. So the way that I can think about that is x is going to be equal to 14 minus 3y. Right, so essentially this is the only equation I've got, and then I'm rearranging it so that I've got x in terms of y. So if I do that, then I'm thinking about my solutions. You might notice that since I've got two unknowns with a single equation, I should have infinite solutions, right? So I set y equals t to be my parameter, right? So I'm going to say t is, right, so y can be any number, and we'll call all those numbers t, and then x is going to be equal to 14 minus 3t. Right? So I would write my solution as 14 minus 3t comma t. And so this is something that we've all kind of done before. It's examples that we worked on in class. And this is mostly just kind of getting used to the terminology that the book is expecting. And normally, so the way that we set up the parameter variables is if you just have one, then you're going to use t. If you had two parameters or two free variables, then you might have s and t, and so on. So if you have three, then sometimes you have r and s and t. Okay, so the other idea is back substitution. So in back substitution, suppose I have a system, right, where x is x plus 2y plus 3z equals 16, 4y minus z equals 6, and z equals 2. Then in this case, right, I need to solve for x, y, and z, but I've kind of got a pretty nice setup because if z equals 2, so I'm using this equation here, right, to say 4y minus 2 equals 6, right, because the z equals 2 going in where z was, and I end up with, right, 4y equals 8, so y equals 2, and then I can use y equals 2 right up here, z equals 2 here, and so I get x plus 4 plus 6 right, equals 16, and I should get x equals 6. And so my point is going to be 6, 2, 2 would be my solution vector. Hopefully that helps. And then again, one of the problems kind of asks you to put these two ideas together, where you're going to use parameterization to figure out what z is, and then use back substitution to find x and y in terms of that. So hopefully that helps. I will see you in class.